Mikko Heino. Mikko is a fisheries biologist who coming to us from the University of Bergen in Norway. He tells me that he has a personal affection for trees, so he's already endeared himself to me, and is going to give us a presentation on fisheries-induced evolution. Mikko.
Thank you, Frances. Ladies and gentlemen, let me set a little bit the stage. For those of us who are from industrialized countries, we tend to see fish as maybe hobby or kind of luxury food. We know it's healthy, but some of us don't like fish, some do, but it's a personal choice. In developing world, it's a bit different. There, fish actually are important for food security. On a global scale, fish are making an important contribution to the intake of animal protein, and it so happens that this share tends to be higher in low-income food deficit countries. And of course, these mean values, they hide a lot of variability. Some people never eat fish, some eat fish every day. So where these fish are coming from? As Dr. Ulf Diekman told us Wednesday, a very significant contribution is nowadays coming from aquaculture. We also heard from Professor Alcamo that in freshwaters fisheries are very important. But still, the biggest single source of fish are marine capture fisheries, so wild marine fish. And this graph, that shows the total marine production of wild fish. And as you see, it is showing something that is a little bit alarming. Since about 2 decades, the increase in production has stagnated. And in recent years, it may have even started to decline. And we know that there are every day more and more mouths to feed. So this trend is really a cause of concern. So is there something we can do to reverse the development, or at least halt the decline? Well, in essence, the question is to take better care of the resources we have. And kind of traditional solutions that are being offered is to save the small fish so that they manage to grow big and reproduce before they are caught, and also to reduce the pressure on overfished stocks. And we know from experience that these help if they can be implemented, which is not easy, but still. However, it may be that these solutions are not alone enough. The reason is that fishing has also an evolutionary dimension. And to understand this, it's useful to understand that growing big is advantageous in ocean without fishing. And why is that? That's because big fish are highly fertile. They produce many offspring. Also, big fish, they have few natural enemies. So basically, to eat a big fish, you need even a bigger fish. And there are fewer bigger fish than smaller fish. So then, of course, you can start asking why not all fish are big? Well, that's simply because growing big takes time and it takes resources. So there's kind of a cost of waiting. And this waiting cost, that's dramatically increased if we start fishing. So basically, growing big takes time, you're exposed to more fishing, it's more risky. So in a modern ocean with a lot of fishing, actually growing big is not a good idea at all. In addition to risk, it's also that we like the big fish. We like to eat the big ones. So fishing as a process favors small fish. So the theoretical prediction is that fishing should favor fish life histories that turn over faster, earlier maturation, and so forth. And interestingly, this is what we see in data. This is an example from Norway. It's a cod from the Barents Sea. It's the single most important fish resource for Norway, also a significant resource for Russia. And in this talk, a trend towards earlier and earlier sexual maturation has been documented. And with the methods we have developed here at IIASA, we have been able to make a stronger case that part of this decline you see in this graph is caused by evolution. So evolution is happening because of fishing. And this we have, and other people have documented in a large number of other fish stocks. Here just a few examples. So what's the link to fish and food security? Well, I have one good news for you. That is that fish that are adapted to fishing, they tolerate more overfishing. So evolution can make fish stocks more robust. However, I have also two pieces of bad news. The first one is that the fish that are adapted to fishing tend to be smaller. And usually we attach less value to small fish compared to big fish. But maybe what is even more important is that we often expect that fish that are adapted to fishing, they are less productive. So the sustainable yield is expected to go down as a consequence of such adaptations. Of course, these changes are quite gradual. But as with climate change, these changes being gradual does not mean that they can be ignored in the long run. We are speaking maybe losses of some tenths of a % per year, which sounds nothing. But if you let such changes to happen year after year, after a few decades it becomes significant losses. And as we know, population is increasing, so we would rather see the opposite development and not this gradual erosion of productivity. So clearly we would like to do something. We would like to minimize such unwanted evolution. Are there any solutions? Well, there's one solution which is simple and robust, and that's to fish less. When you know that the problem is caused by fishing, it's not surprising that fishing less is maybe part of a solution. What is positive with this solution is that fisheries scientists have been advising this for many other reasons for a long time. So there's a synergy between caring about unwanted evolution and traditional fisheries management. But of course, that fisheries researchers have been advising this also is an indication that it's not actually so easy to achieve it. Fish are often shared resources, nobody easily owns them, and managing such commons is known to be difficult. Okay, so beyond this simple qualitative advice, often we would like to have something more concrete, something more quantitative. And in this context, it's important to recognize that, of course, avoiding evolution is just one piece in a big puzzle. So it's only one of many objectives that we need to satisfy. So basically, we need a framework to assess costs and benefits of reducing evolution, taking an integrative approach where we also include other considerations in the account. And this is also something we have been developing here at IIASA over past years. We have coined it evolutionary impact assessment. And if you want to learn more, you can check my poster. It's in Kaisergang. Thank you for your attention.